Greetings everyone! Today we're going to explore graphing and writing ellipses translated. So in our previous video we just graphed ellipses and they were always at the origin. So now we're going to talk about what that horizontal and vertical shift looks like, and we're going to write them based on information or graphs. You definitely need the foldable today to make this more efficient. So let's talk about what an ellipse looks like when it's moved. We know our formula previously was x squared over a squared plus y squared over b squared equals 1. Now we're adding that center being shifted. And so if you're comfortable with circles, to start off with, you're going to be comfortable with this shift. If my x says plus 2, that means left 2. If my y says plus 3, that means down 3. So let's jump into graphing. So you'll need to make sure you're on example 5 in the foldable. First thing, my equation is equal to 1. Remember from the previous video, it has to be equal to 1 to be an ellipse. We have a plus sign, which also implies an ellipse. So everything is looking as it should. The major axis. The major axis is the x-axis because that's where the larger denominator is. It's under the x. That means it's going to be a horizontal ellipse. Again, if you're struggling with this information, you definitely need the previous video. My center point. So here's what's new. If it says x minus 3, my x is positive 3. If it says y minus 5, then my y is positive 5. So let's go graph that right away. Here's my origin, my center. I don't know why I said origin. It's my center shifted from the origin. All right, vertices. Now, here's where I definitely recommend graphing them and then writing them. From that center point, my major axis is the x. I'm going to go left or right. And if it says 49, the square root of 49, right, is 7. I want to go 7 in each distance. That means I'm going to exist here. Oops, 3, and I'm going to exist here. Those are my vertices. See how it's easier to graph them and then write them? So my vertices exist at 10, 5 and negative 4, 5. Now, those of you that can do those calculations super easy, you might just say, oh, what's 3 plus 7? What's 3 minus 7? That's how we get the x values. I'm visual, so that's why I encourage graphing. Let's talk about co-vertices. Square root of 4 is 2. So that means I'm going to go 2 in each direction from the center. Those points are going to keep their x value, but my y value went from 5 plus 2 and 5 minus 2. Now, we have our vertices and co-vertices. Oh my goodness, as you know, I'm horrible at graphing on this tablet. Let me try one more time. So we have our ellipse. It's a little better. Not much. All right, let's talk about the foci. We need an equation. Do you remember the equation from the previous video? A squared minus b squared equals c squared. Remember, a squared and b squared are your denominators, so I'm just going to take care of that right away. The larger value minus the smaller value would be 45, right? 49 minus 4. I'm going to square root both sides. So c equals plus or minus. 49 breaks down to 9 and 5, which is 3 radical 5. Now, here's where things change. From the center point, I'm going to add 3 radical 5. So let's talk about what 3 radical 5 is as a decimal first, maybe. So let's take the squared root of 5, and we're going to times that by 3. You might just type in your calculator all at once. But that gets me to, and I'm just going to jot it down here, approximately 6.7, right? So from the center point, if I go 6.7, I'm really close to the vertex, right? So look at where those yellow dots are. Now I'm going to write them. This takes some practice. The y value stays the same as the center, so we're going to have comma 5s on both of these. Now, we want to go to the center x value, which is 3, and we added 3 radical 5. Then we went to the center and we subtracted 3 radical 5. So we are not going to have decimal or these nice, pretty, clean values for our foci. We're going to have almost, it's going to be like a little expression. You're going to have to write quite a bit. So take the center value, add or subtract that distance. Let's jump quick. We'll have some extra examples at the end, but let's jump to the writing portion of this foldable for ellipses. Let's start off. You'll want to find example 15. This one's given a graph. To be honest, graphs are just easier, but let's talk about the setup. Remember, it's going to be an x quantity squared plus a y quantity squared. It's an ellipse, so it has to be equal to 1. Okay, let's talk about the center points. Now you can count the distance and find the middles. We would exist right here. So from the origin, that point would be -4, 2, right? -4, 2. So if my x is -4, I write +4. If my y is 2, I write -2. Now we need the distances. You'll notice that the major axis is the y-axis. We have a distance of 1, 2, 3. Let me go like this, actually, a little easier to see. 1, 2, 3, 4, 5, 6, 7. There's a distance of 7 there. It's vertical, so under the y, I want 7 squared. Let's look at the minor. The minor axis, left to right, there's a distance of 2. So we write 2 squared under the x. Where you place that 49 and that 4 determines the orientation. Not quite as easy as from information. So, marker boards. If you want to pause and get a marker board and jot these little pictures down, I strongly recommend that. I'm going to do a generic sketch, but if you can use an exact graph, even better. So, quick little sketch. 2, 13 is a vertice, and 2, -1 is a vertice. Now, that's my vertice, which means this has a major axis of a y-axis. It's going vertical, okay? My co-vertices are at 5, 6, which is in the middle, right? That kind of makes sense. And -1, 6. Oops, and that's kind of a little too far off for my little sketch. So I have an ellipse that's vertical like that. First thing I want to do is find my center. Sorry, that's a horrible image of an ellipse here. Let's try to keep it through the vertices. So let's set it up. Quantity x squared plus, that plus sign matters, y quantity squared equals 1. My center is going to be in the middle. So if we talk about its x value, the x's, the covertices, are 5 and -1. The middle of those values is 2. So if my middle value is +2, I write -2. Let's talk about the y's. The y values on the vertices are 12 and -1. The middle of those would be 6. Right? Here's how my brain's doing this. I'm doing 13 plus 1, which is 14. 14 cut in half is 7. So I want to go 7 from either point. So if mine's +6, I write -6. Now those values I just talked about, I just said how this has a distance of 7. Under the y, I want 7 squared. Let's talk about the distance from the x. Right? The distance from the covertex to the center was 3. So 3 squared is 9. It has to go under the x. Again, pictures are so helpful. The more accurate, the better. All right, let's talk about this next example, number 17. Look at what we're given. We're given the vertices and the foci. So I definitely encourage using your marker board or a graph to get an image in your head. I'm going to try to create a sketch. You'll notice that they're all positives, so we're only dealing with the first quadrant. So maybe that actually makes it easier to sketch. So I'm going to do with the first quadrant. I have 4, 13 is a vertex, and I have 4, 3 is a vertex. So that means that the major axis is the y-axis, it's vertical, right? The foci are at 4, 11. Well, that makes sense, right? I'm getting this image in my mind, and 4, 5. Oops, I don't know why I put 13 over here. Sorry about that. That's 4, 3. So this one was 4, 5. Makes sense, okay? So in my mind, I'm just going to do just a generic sketch here for a second. It's going to look skinnier through the vertices, right? I'm going to start setting this up and see what I can come up with so far. X quantity squared plus y quantity squared equals 1. Let's talk about the center. I can find the center point. The center is going to be somewhere around here, right? That means my x point is definitely 4. My y value, the distance from 13 to 3 is 10. Cut 10 in half, and my distance would be 5. 13 subtract 5 gets me to 8. Now, if you have graph paper in front of you, it's going to be way easier to find that center point, right? I actually have to calculate since I don't have a graph. So if my x is positive 4, I write negative 4. If my y is positive 8, I write negative 8. I know that my vertical distance from my vertex to my center is 5. So because of that, I can write 5 squared under the y. Here's what I don't know. Here's where my work really comes in. I don't know where my co-vertices are. I know they exist at a y value of 8, right? But I don't know their x values. So we have to find them. Yep, we need to use that little formula, that little a squared minus b squared equals c squared. 25 was my vertex to center. That's my larger value, so it comes first. I'm going to subtract. I don't know my shorter value. I don't know what the distance from center to co-vertex is, so that's going to remain b squared. I do know my c value, the distance from my center to my focus. 8 to 13, excuse me, that's not 13. Sorry, that's 11. Oh my goodness. I don't know why I wrote 13. 4, 11, right, from here. The distance from 8 to 11 is 3, or the distance from 8 to 5 is 3. 3 squared is 9. We can solve this. This is just a regular equation. Let's subtract 25 to the other side. Negative 16. Let's divide by negative 16. The square root of 16 is positive and negative 4. Look at that, works out so nice. Okay, but b squared is 16, and in the formula, I actually want the 16, right? Because we take the distance squared. Now, how does the 4 help me? The 4 helps me if I need the points, right? 4 plus 4 is 8. 4 minus 4 is 0. That's where the 4 would help. Again, kind of crazy. If you're using graph paper, much better. Maybe consider if you didn't have graph paper to get some and try again. Let's really have some fun here, okay? Again, I know these are longer videos. This is all new information. Again, please have your marker boards. Try it with a marker board. It'll help a little bit. All right. We are dealing with all negative x values, positive and negative y values. So we're dealing with the second and the third quadrant. Co-vertices are at negative 10, 8, and negative 10, negative 16. My foci, so if those are my co-vertices, I know that my major axis is the x-axis, right? I'm just going to envision this. It's like it's going to go like this somehow, right? Foci. Oops, let me get back to my pen. My foci are at negative 5, negative 4, and negative 15, and negative 4. Kind of makes sense with the little picture I created in my mind. So first thing, I'm going to set up my little equation. X quantity squared plus y quantity squared equals 1. I can find my center point, right? My center point, if I got co-vertices, I can find that center point. The middle value, it's definitely going to be negative 10. And the middle value between 8 and negative 16. Well, if 8 plus 16 is 24. 24 cut in half is 12. The distance is 12, which takes this to a negative 4. So x plus 10 is what I need, and y plus 4 is what I need. The smaller value goes under the y. 12 squared is 144. Do you see where I got that? The distance from the center to the co-vertex squared. Let's go and find the distance from the center to the vertex. I don't even know where my vertex is. So we got to do a little bit of work. A squared minus b squared equals c squared. My shorter value, center to co-vertex, was 144. That was my b squared. I don't need to square root it. I don't know my longer distance, but we can work with c squared because I know my focus. My focus was at negative 5, negative 4. The distance from the center to the focus, negative 10 to negative 5, is 5. Or we could use the other side, right? Negative 15 and negative 4. The distance, still 5. 5 squared, 25. Okay. Again, graph paper, so much more helpful, so please consider it. Let's solve for A. I am going to add 144, that's 9, 6, 169. Square root of 169, again, I'm not going to give you anything too crazy. Square root would be 13. All right, the distance. A represents the distance from the center to the vertex is 13. I know my y value is negative 4. If my center's at negative 10 and the distance is 13, then I exist at 3. Or let's go the other way. If I go over here, right? If the distance, it'd still be a y value of negative 4. If I start at negative 10 and I go 13 left, that would be negative 23. Either way, 13 squared, oh, I already had that, was 169. It makes sense. So that's again why I encourage graphing, because it should make sense. All right, at this point, it is up to you if you want to keep watching. I'm going to do a couple additional graphs here. Again, you decide what you need. This isn't part of your notes packet, so you would need some extra graph paper to make this happen. So let's start off with my major axis. It's under the x, so it's going to be the x-axis, which means it's going to be horizontal. My center point, my x value is 0. If it says y minus 8, I write positive 8. So my center exists up here on the graph. Vertices. All right, I'm going left to right. Square root of 64 is 8. Right? Square root of 64 is 8, which means I'm going to go 8 in each direction horizontally. That means my vertices exist at 8, 8 and negative 8, 8. Covertices. The square root of 9 is 3, so we're going to go 3 in each direction. That means my covertices exist at 0, 11 and at 0, 5. You could create your sketch, of course. Yours is going to be so much better than mine. Connect those dots. Oh my goodness. Foci need to be somewhere in here, right? That's what we're expecting them to be. Let's use our formula. A squared minus b squared equals c squared. 64 subtract 9 is 55. Take the square root of both sides. That's positive and negative. Let's see if I can reduce that radical. I don't believe so, right? Is it going to stay square root of 55? Now let's see what the actual value is. Let's use our calculator. I am using mine as I record this. 55 square rooted would be about 7.4. Hey, that makes sense. We're really close to the vertices. So as I write this, I'm going to set it up first. The y value is going to stay the same as my center. It's going to be 8. My x value, conveniently, we were at an x value of 0. 0 plus square root of 55 and 0 subtract square root of 55. So I don't really need the plus sign, but there we go. Again, always reduce radicals if you can. The graph is very helpful to decide what those point values are. Do you need one more? It's up to you. I'm going to leave this one blank. I think we're getting the gist of it. But here it is if you feel like you need some extra practice or something to work with on the next learning check. Feel free to pause, screenshot, use as you need. Oh my goodness, I know it's a long one, you guys. This unit is tough. It's new. It's a lot of new stuff. Let me know what questions you have. We're going to keep working on this. Make sure to check out Google Classroom to see what your task is and what other resources there are. Seek out other YouTube videos, right? Maybe another teacher is going to just make it click or connect even better. Keep in touch. Let me know what you need. And until next time, have a good one.